Welcome back, students who are taking Math for Business and Finance and Math Applications. We're moving on with the Chapter 12 drill problems, the odd-numbered problems that were assigned in your study guide. And even though we took the entire video for problem 12-1 in the last video, yes, we showed 2 out of the 3 different methods of being able to do that. Now I'm going to be moving through these problems a little bit quicker because depending upon what the question asks, I'm just going to end up using the tables most often. So I'm not going to be doing much by hand unless, of course, the problems ask me to do that. And I'm also not going to be addressing the issue of how do you enter it in the calculator, okay? But if you do have questions on those, definitely telephone and speak with an instructor, okay? So, drill problem 12-3. Complete the following using the compound future value table. That should be a T for table. Make sure you're getting the right table, okay? You'll get, when you look at both of them, you'll see that the factors are very diverse, and you'll get a feel for it, meaning, like if I have a present value, then in the future, generally the number should be greater than 1, because let's face it, let's say I have 10%, and I'm just going to write this down real quick. If I have 100%, which is the present value today, and let's say I have an additional 10%, all right, well then that's 110%. So my factor should be greater than 1, right? Because if I convert the 110% into a decimal, I get 1.10. So greater than 1, if I'm looking out into the future, those factors should be greater than 1. And conversely, if I'm looking at a future value table, they should be less than 1, okay? So that's why when you look at those tables, you see 0.423 for the present value, but yet for future value, you see, 2.12, that type of thing. So, I'm just warning, just make sure you're choosing the right tables, okay, when you're doing the problem. If you're thinking about the problems, then you shouldn't have too much of an issue, okay? So, okay, we're looking here, my time frame is 6 months, my principal is 15,000, my rate is 6%, and I'm compounding semi-annually. So semi-annually means twice a year, right? So remember, with the rate, we're always going to divide by the compounding period. So 6 divided by 2 is 3%. And for the time, we're always going to multiply by the compounding period, okay? Now, here's the thing with this. This time is, in this respect, for this problem, remember, time is, we're thinking in terms of 1 year, okay? And in 1 year, when you compound semi-annually, there's 2 periods, which is every 6 months, okay? Well, what's our time frame? It's already 6 months. So that's, we don't need to do anything to that because it's a compounding period of 1, all right? So our interest rate is 3%, and our number of periods, this is compounded semi-annually, our number of periods is 1 because it's already half of the year, okay? 6 months over 12 months is 0.5, and you multiply that by 2, gives you 1 compounding period, all right? That's the math. That's the theory behind it, okay? So in order to do this, let's see here. It's probably, it's easier to take, and let's look at the future value table. And we're looking at, that's present value, that's future value. And we are looking at 3% for 1 period. And that gives us the factor of 1.0300. So I take my 15,000 and I'm going to multiply it by 1.0300. and that's going to give me, let's see, 15,000. Okay, so that's going to give me 15,450 as my total amount. Now remember, the total amount is the principal plus the interest, right? Because 1 is the 15,000 and the 3% is the additional interest. So principal plus interest. And in order to be able to find the interest, we take the principal amount and subtract it from that total amount, and we're left with the $450 of interest. Okay, and that was relatively simple. All right, and you'll notice that this is the same pattern. Okay, remember I had a long time ago I had talked about patterns, right? Understand the concepts and apply your understanding of the concepts to the problems, but you'll start to develop a sense for a pattern. You know, what's the pattern that we're going through here? Okay, one, I'm looking at my, you know, how often it's compounded. Number two, I look at the interest rate and convert it due to the compounding periods. Number three, I look at the number of periods, the time, and I convert it due to the number of periods. Then I go and I look on the table. So that's like step number 4. That's part of the pattern. I look on the table for the factor, and then I multiply the principal times the factor, and I get a total amount. From the total amount, I subtract out the principal, and I end up with my interest. Okay, so that's the pattern, right? Just keep on following that pattern. So here's the factor. This would be step number 5, and this would be step number 6, and I'd end up with my interest at step number 7. Okay. Okay, drill problem 12-5. Okay, so this one here is calculating the effective rate, the APY, of interest for 1 year. Okay, remember the effective rate was the APY, the formula was the interest for 1 year over the, let me get it here, over the principal. Okay. So we need to find the interest, right? Okay, so we're starting out here with principal of 15,000. Our interest rate is 12%. Compounded quarterly, which means 4 quarters in a year. And we want to know what the APY is. Okay. And this here is based upon 1 year. Okay. So our interest rate is, so our compounding is 4 periods. Our interest rate is 12% divided by 4, which gives us 3% interest. And our number of periods, since it's 1 year, that's 1 year times 4 compounding periods in a year. So that means there's 4 periods. So we're going to use the 3% interest and the 4 periods, and we're going to look at our future value table. And on our future value table, we look at, there's future value, so we have 3% for 4 periods, and that gives us a factor of 1.1255. So our factor, there you go, so our factor is 1.1255. So we still need to figure out how much interest, so we have 15,500 times the 1.1255, and that's going to give us a total, which is both the principal and the interest. Okay, and that amount ends up being, when you do the math, 17,445.25. Now remember, that's principal plus interest. That's the total. And we just want to know how much the interest is at this point in time, because we know the principal is, you know, the 15,500. So we subtract the 15,500 and we end up with interest of 1945.25. Okay, so that's our interest. All right, now, since we know that's our interest, all right, we can now calculate our APY, which is our interest for 1 year. So our interest for the 1 year is going to be the $1,945.25, and that goes over our principal amount of $15,500. So when you divide one from the other, you end up with 0.1255, and in a decimal form, in a percentage format, it's 12.55%. Okay, and again, notice that APY is that 1255 is different from the interest rate of 12%. That 12% is the nominal rate. Okay, that's the stated rate. But due to the compounding effect, our effective rate is actually greater because why? We're getting interest upon interest. And that's what accounts for, in this particular case, the additional 0.55%. Okay. All right. So with that, I'm going to stop here. And again, if you don't understand something, go ahead and rewind and watch the video. And if you have a question, feel free to call. All right.